Hello everyone and welcome to the lecture on kubectl storage commands, and in this lecture I will walk you through storage classes, persistent volume and persistent volume claims. So first we'll set the alias k equal to kubectl. Next, something about scope. So storage class is cluster scope, so it does not belong to any namespace. It's like the global catalog of all the storage types. Persistent volume, short name is PV and this is SC. Again, this is also cluster scope, so it does not belong to any namespace. And this is like a central pool of available storage. Lastly, persistent volume claim. This is PVC and this belongs to a specific namespace. So if you don't specify a namespace, it will belong to default namespace. This is a user specific order. So user is basically ordering for storage. Next, how to get storage class. So you will type k get sc. And this will list all available storage classes. This is the first step to see what types of storage are available for provisioning. And you will get output something like this. There will be name, who is the provisioner, reclaim policy, it will be like delete or retain, volume binding mode, immediate or wait for first consumer, allow volume expansion, true or false, and lastly age. So this is in days. Next command, describe storage classes. So k describe sc followed by the storage class name. So this shows details of a storage class including its provisioner, parameters and reclaim policy. So the output may look something like this. Name is default class, yes or no, annotations, provisioner, parameters, allow volume expansion, true or false, mount options, reclaim policy, volume binding mode. Next we have set default storage class. So you can use the edit command also, but how to set the default storage class? So you will run k patch sc storage class name, and inside metadata annotation storage class Kubernetes IO is default class. You have to just make it true. So after this, every time you ask for persistent volume and or volume claims, this will be the default if you don't specify any specific storage class. So this marks a specific storage class as the default for the whole cluster. And you will just get an output saying that it is patched. Create storage class. So you will apply a storage class manifest YAML file. So this one you cannot be done through imperatively, like you cannot do k create something like that. So this creates a new storage class from a manifest file. And let's say the manifest file may look something like this. You have kind equal to storage class, metadata name, who is the provisioner, volume binding mode, and this is wait for first consumer and reclaim policy. Then you just do a k apply and the YAML file name, and you will get output saying that storage class is created. Next, explain storage class field. So you can run k explain, and if you are interested in specific field, you can say sc.reclaim policy, or you can just say sc. So it will explain the whole storage class YAML. So it will basically to quickly get documentation on any field or the whole thing. So as I talked about, it will be like delete or retain, and the output will be something as shown over here. And you can read more in case you are interested. You can find out more information like how it will behave when you have a reclaim policy as delete or when it is retain. Next we have list persistent volume claims. So you can say k get pvc dash name and the namespace name. So this will list all persistent volume claims in a namespace and checks their status, whether it's pending, bound or lost. And output may look something like this. The persistent volume claim name, status, bound or pending, and to which volume it is bound. So this is volume claim. So this will be like this will be requested through the deployment or a pod. And how much got bound is like 10 GB byte or 5 GB byte, read write access modes, and storage class, like from which storage class this persistent volume came from. So this is like premium RWO, standard or fast SSD. Then describe persistent volume claims. So you can say k describe PVC followed by the PVC name and namespace name. If you omit the namespace name, it will try to find out in the default namespace name. So this is the most important command for debugging persistent volume claims. The event section will tell you exactly why a PVC is pending. So this is how the output may look like. So you have the name, namespace, storage class, status, all those things. But you have to go to the events whether it got bound or not. So you will see something like external provisioning failed, and you will have some message saying that it's not found. So in case you have asked for some storage class through persistent volume claim but that name does not match, you will get some message like this. So create persistent volume claim. So k apply and the file name. So we cannot directly create imperatively saying that k create or something like that. So this will declaratively creates a persistent volume claim which a pod will then mount. So it will look something like this: persistent volume claim, then the metadata like name and namespace, then specification, access modes like read write once, and how much resources are required. So this is asking for storage of 10 GB byte and from which storage class name. So once this is bound, then any pod can get the persistent volume through this claim. So pod, you have PVC and you have persistent volume. So pod will use this to go to the volume. And you can just apply the file and you will get a message saying that it's created. Next, to delete a persistent volume claim, you can just say k delete PVC followed by the PVC name and namespace name. So this will trigger the reclaim policy on the associated persistent volume. So you will just get a message saying that it's deleted. Next, list all persistent volume claims. So k get PVC and then dash capital A. This will list all PVCs across all namespaces, and the output may look something like this. So you have all the PVCs, status bound or pending, and to which volume it got bound, how much is the capacity, and what is the access mode, and the storage class name, and how long the age of the persistent volume claim. So this is read write once or read write many. So access mode. Edit persistent volume claim. So you can directly do k edit PVC and the name followed by the namespace name. So this allows live editing of a PVC, for example, to request more storage space if the storage class supports volume expansion. And the output will look something like this. So you will be straight away shown the default editor. If it's, let's say, VI, so it will open up in VI, and you can go to the specific field. For example, in this case, let's say you want to change the storage. So from 10 GB byte, let's say you want to reduce or you want to expand. So you'll change this particular field and you'll just save the file and it will immediately take effect. Next, we have list persistent volumes. So this is cluster wide. So what we have talked about, PVC is where namespace specific. So we can say k get PV. This is clusters wide, so we don't have to specify the namespace. So this is assume that it's whole cluster. So this list all persistent volumes in the cluster, shows capacity, access modes, reclaim policy, status, whether available, bound or released, and which claim it is bound to. So output may look something like this: persistent volume name, capacity, access mode, read write once or read write many, reclaim policy, delete or retain, status bound, available or released, and which claim it is attached to. So this is PVC name, and this persistent volume is using what storage. So underlying storage class name. So there is a default storage class, and let's say you work on a cloud, you can have fast SSD and HDD or slow SSD. So all the storage classes will be there, and the age. So how long it's been up and running. Next, describe persistent volume. So k describe then PV followed by the persistent volume name. This shows detailed information about a persistent volume, including its specification like host path, NFS path, and the claim reference, which links to a persistent volume claim. So this is how it will look like. Describe command. So you have the name and any kind of annotation, which storage class it is part of, status, and who is the what persistent volume claim it's claiming this persistent volume, reclaim policy, access modes, and volume mode, capacity, any node affinity, and you have sources like this is container storage interface, volume, and more information about what is the driver, what is the file system type, volume handle, read only, and any volume attributes. And to create a persistent volume, we will do kapply, and again we have to have a YAML file. We cannot do imperatively. So this creates a PV manually. This is known as static provisioning. And let's say you have this NFS persistent volume. You can declare this YAML. You can provide a name. Namespace is not required. Specification, storage 10 GB byte. Volume mode, file system, access modes, read write many. And persistent volume reclaim policy is to retain. So if there are no PVC attached, it will still the data will be retained. And storage class name manual NFS. So this is first we have to create this, and this is volume. Persistent volume is attaching to that storage class name. And what is the source? So this indicates the exact location of the storage. So this is saying this is attached to network file system, and the path to which it is attached is here on this particular server. So this server is serving this path, and this persistent volume is being attached or bound to this location. Then you just do a apply, and you will get a message saying that it's created. Next, to delete persistent volume, just kdelete PV and the PV name. So this deletes a PV from the cluster's inventory. This does not necessarily delete the data on the underlying storage medium, for example, NFS share or cloud disk. So you'll get a message saying that it's deleted. And to unbind a persistent volume, you can use the edit command, but you can patch also. So if you do edit, you have to go to this particular section. So you can just go to spec. So this is the high level root. At the root level, then spec claim reference, you can just make it null. This manually removes the claim reference. Claim reference is persistent volume claim from a persistent volume whose status is released. This makes the persistent volume available again for a new persistent volume claim to claim. So for example, you have k get PV and the name, and you would provide -o output wide. You get all the information, right? Then you take, for example, this persistent volume and you just make it claim reference as null. So previously this was the claim. After you make it null, this will go away, and you will get a message saying that it's patched, and you run the same command. You will see this claim has been removed. Now this is available for any pod to be associated through the persistent volume claim. So basically you are releasing the storage. Describe pod for any volume mount issues. So what you can do, basically you have to describe the pod and then check a pod's events to see if it is having trouble mounting a volume. So this is how the output may look like. So you do a kget, you get the pod name, then you do a describe, and under describe you should just scroll down to the section where events and volumes are there. So a reference to persistent volume claim in the same namespace and the claim name and all. But under the events, you will see something like this: unable to attach or mount volumes, timed out waiting for the condition. So in case there is not enough disk space or something, you will get some or the name or the YAML is not correctly correct, or some those kind of issues you will see. So you'll see like container creating, because it's not able to get the persistent volume through the persistent volume claim. And last, we have list all the PVC and PVs. So you can run one command and see all the information. So this is PVC is only for namespace, but you can run something like this. A quick way to see both the claims and the volumes. They are bound to in a single view. So you can see all the claims and the PVs persistent volumes. And from here you will be able to actually make out whether this is bound to which. So for example here, so this claim web app PVC. So this one is this item or this object over here, and there are others also, but this is for dev team only. So that's why we are seeing two, but here we are seeing across the whole cluster. Next is to see any provisioner logs like container storage interface provisioner logs. So you can do k logs, and their CSI provisioner has specific pod which live in the kube system namespace, and to debug dynamic provisioning issues at the source. If a PVC is pending and describe gives a generic error, the logs of the actual storage provisioner pod will have the details. So this may look something like this. You can k get pods. You can grep for provisioner. So we have, for example, Google Kubernetes engine or CSI pod, which is for storage interface. Then you can find out. You can do k logs and the pod name and kube system. Then you can find out detailed information about the specific log, what is the issue. And that's all. Thanks for watching.